Hello everyone, so we're going to be talking about multiplying and dividing polynomials. Now, before I even start, I just want to show you something in your text because many of us have heard of this before and I personally cannot stand this. So, what I want to show you in your text is this. We're going to copy and paste it. So when we are multiplying polynomials, okay? The one thing that teachers always do is they always say, okay, well, we're going to start off by multiplying two binomials. So if you remember, a binomial looks something like this. Like the quantity x plus 3 times the quantity x minus 7. Okay? Now, when we go to multiply polynomials, all we're doing is we're using the distributive property over and over again. All right? That's all we're really doing here. So many of us, if you remember from back in the day, you were taught this thing called FOIL, all right? And this is the only time I'm going to say the word FOIL, because after this, I'm never going to say the word FOIL again, because I hate the word FOIL, because FOIL is a terrible way of teaching this. And the reason why it's terrible, it only applies to two binomials, and that is it. And the likelihood of you doing are you multiplying two binomials for the rest of your life, or at least in the smaller sense for the rest of this course or the rest of your math career, is infinitely small because we're always multiplying polynomials in general. So how do we multiply polynomials? Well, like I said, we are constantly going to be going over the distributive property. We're going to be using that over and over again. And a nice way to organize everything is using what we call the vertical method. So get rid of that F word. You know what one I'm talking about. I'm going to erase it right now. There it is. Now we're going to scratch it out because this is absolutely terrible. It's a bad way to teach math. Okay? So what I want to do is I'm going to show you how to multiply polynomials first. And then after that, we're going to divide polynomials. And then that's it for this. It's a very easy week. So here we go. We're just going to dive right in. The key to multiplying polynomials . The key. All those rules for exponents we learned earlier. Rules for exponents. Now, a lot of this should be kind of like a little bit of a review for us because you would have seen something like this in Math 90. Maybe not to the extent that we're going to be looking at it, but you may have seen this before. So part A, a nice easy example would be something like x times the quantity x squared minus x minus 6. Once again, we're going to use the distributive property. We're going to distribute the x. And applying our rules for exponents, x times x to the second is x to the third. X times negative x is going to be minus x to the second. And then finally, x times negative 6 is negative 6x. All right? So there is like our very first example. Nice, straightforward, to the point. All right? Let's do another example here. Nothing too crazy. All right? But we're going to ramp up the difficulty a little bit. So how about 4x squared multiplied by 6x to the third minus 2x to the second plus x plus 4. So once again, distributive property. 4x to the second times 6x to the third is going to be 24x to the fifth minus 4 times 2 is negative 8. X squared times x squared is x to the fourth. 4 times 1 is positive 4. X squared times x is x to the third. And lastly, 4 times 4 is positive 16. X to the second. All right. Now, notice the directions. Multiply polynomials. So here's our next polynomial that we're going to multiply. And it's going to be the one that I reference at the very start of this. The quantity, x plus 3, times the quantity, was it x minus 7? Yep. Times the quantity x minus 7. Now, what I'm about to do, a lot of us are going to go, well, Professor, you just applied that F thing that we were talking about, the FOIL thing. Oh, I can't believe I said it. Oh, well. And I'm not going to disagree with you, all right? But the thing is, if you understand how to use the distributive property, you never have to memorize that FOIL technique thing. And I said it again, and I said I wouldn't, but I did. And then you can apply it to any type of problem. So the key behind this is that, remember, all we're doing is we're distributing the x to the x minus 7 and the 3 to the x minus 7. Okay? Now, the way that I'm going to do this is I'm going to use the vertical addition method just to organize things. So watch what I do. I'm going to take x times x and write x squared. Then I'm going to take x times 7 and write negative 7x. Now, I'm going to go ahead and distribute the positive 3. So we just did this thing right here. Now, let's distribute the positive 3. And watch how I write this. 3 times x is positive 3x. And then 3 times negative 7 is negative 21. This is called the vertical method. And the reason why we call it the vertical method is as soon as you distribute and you group your like terms just the way I did this, you add vertically straight down. X squared minus 4x minus 21. Now, I know some of you may be sitting there saying to yourself, yeah, but you just did that thing that you said you wouldn't do. And like I said, I'm agreeing with you. We have a binomial and a trinomial. And remember that thing we were talking about earlier, the thing that we said we wouldn't talk about? Let me scroll up so we can at least look at it. This method only works when you have two binomials. We no longer have that. In fact, so far we've done 4 examples. Well, we're going to do 4 examples, and only one of them actually met this criteria. So my approach to when I go ahead and I'm teaching this is, why don't we just learn how to do this the proper way instead of worrying about like the exception, which is that thing that we're not going to talk about anymore. So the way that we approach this is we're going to distribute, and we're going to organize this using the vertical method as we go along. So I just want you to maybe watch the screen, try to anticipate what I'm going to do. So the first thing we're going to do is distribute this x. So we get x times x to the 4th, x to the 5th, plus 2x to the 4th minus 7x to the 3rd. Okay? So there's the first distribution. Now, we're going to go ahead and we're going to distribute that positive 3 to every term. Okay? And as we progress, we're going to group our like terms in the second row, like I said, going from left to right. So, like I said, just watch, anticipate, try to see what I'm doing. 3 times x to the 4th is positive 3x to the 4th. 3 times positive 2x is going to be plus 6x to the 3rd. And then 3 times negative 7 is going to be negative 21x to the 2nd. And as you can see, using this distributive property, which we're all familiar with, and just aligning things as we go, using that vertical method, we're automatically grouping our like terms, and it looks all nice and neat, and everything is organized. Now we just come straight down. X to the 5th plus 5x to the 4th minus x to the 3rd minus 21x to the 2nd. And that is how difficult this gets. Okay? So if you want to keep using that technique that we won't talk about, all right, if you want to keep using this, I say go for it. It's fine with me. I'm not going to reinvent the wheel. However, I just want you to be aware that that is an extremely special case that doesn't always apply, and I can guarantee you this. On an assessment, quiz, exam, final, you will probably use that if there are 10 questions once. You will use the distributive property and vertical method way more. So just be aware of when it applies and when it doesn't apply. I want to go ahead and do just one more example of this, of multiplying polynomials, and I want this to be more of a difficult problem. And like I said, the only way that I can really make this difficult, okay, is to just give you more to do. So like, for example, let's say we wanted to do negative 3x to the second minus x plus 1 and multiply this by 2x to the second plus, let's go 5x plus 1. So once again, we're going to start with the negative 3x squared, and we're going to distribute it to the entire trinomial. So we get negative 3 times 2 is negative 6x to the fourth minus 15x to the third minus 3x to the second. So there's our first distribution. Now we're going to move into the middle term, that negative x. Let's distribute that. So we get negative 2x to the third minus 5x to the second minus x to the first. So there's our second distribution. And then our third, all we have to do is just distribute this positive 1. So we get 2x to the second, and that's positive 2x to the second, plus 5x plus 1. Everything is nice and grouped. Going from left to right, you get negative 6x to the fourth, minus 17x to the third. Let's see, we get negative 8 plus 2. It's going to be negative 6x to the second, plus 4x plus 1. And that's it. So that is as difficult as multiplying polynomials gets. Now, sometimes we get lucky, okay? And what I mean by that is we can kind of save ourselves some time if we can focus on these special cases, okay? So the special cases, and I'm just going to go ahead into our text. I'm going to copy and paste them into our notes so you can see what they look like, because they're directly from the book. All right, so let me find it. Here it is right here. So let's go ahead and let's copy and paste this into our notes. So this is what we call binomial squares pattern. Now, initially, when we're multiplying with polynomials, being able to recognize this is good, but it's not necessary because we understand how to multiply binomials, all right? But it's nice if you can recognize the pattern, especially when we get to factoring, which is the next chapter, and then rational expressions and everything else, okay? So the key here is this. If we can recognize that we have a quantity of a plus b raised to the second power, well, that is going to simplify into this formula right here. So let me show you how this works. So here's an example, and we're going to do, let's do x plus 4 raised to the second power, all right? Now, if we just follow this pattern, what this is really telling us here is this. We're going to let a equal the variable x, and we're going to let b equal the number 4. And wherever I see an a or a b in this formula, I am going to come directly underneath. I'm going to make the appropriate substitutions. All right, so wherever I see the letter wherever I see the letter a, I'm going to replace it with an x. Wherever I see the letter b, I'm going to replace it with a 4. And I'm going to simplify to give us x squared plus 8x plus 16. And that's it. So like I said, you can save yourself some time if you want. We can also do this with the second part of the formula, and I'll do a more complicated example with this. So let's say we have 2x minus 3y quantity squared. Okay? Well, once again, let me write out the formula first. So we got a to the second minus 2ab plus b to the second. Wherever we see the letter a, we're going to replace it with a 2x. Wherever we see the letter b, we're going to replace it with a 3y. Okay? Remember, you don't have to use this negative sign in front of the 3y because you're using a formula. All right? So, directly underneath, let me put my parentheses first. Don't forget my exponents. Good. Now, wherever I see the letter a, I'm going to write 2x. Wherever I see the letter b, I'm going to write 3y. Now I just go ahead and simplify. The quantity, 2x squared, is 4x squared minus 2 times 2 is 4, times 3 is 12, xy, plus the quantity 3y to the second is 9y to the second. And that's exactly what you get there. So, like I said, it's nice if you know the formula, but let's be honest. Let's say you forgot the formula. We know the quantity 2x minus 3y squared is really just the quantity 2x minus 3y times 2x minus 3y. And we also know distributive property, vertical addition method. So if we were to distribute the 2x, you would get 4x to the second minus 6xy. Now, if we distribute the negative 3y, you get negative 6xy plus 9y to the second. And when you combine like terms, you get 4x to the second minus 12xy plus 9y squared. So, like I said, if you forget about these little formulas, which hopefully you don't because all my tests are open notes, open book anyways. But if you forget the formula, you can always fall back on the proper way to multiply polynomials, which is to know your distributive property, rules for exponents, vertical method, and that's it. There is one more special case that we're going to go over, and that's right here. And it has to deal with conjugate pairs. Now, conjugate pairs is one of those things that everybody knows, but they always forget that they're called conjugates. All right, so let me copy and paste this. So what makes conjugate pairs so special is the fact that you have two binomials, and when you look at them, they have the same exact initial term and last term. It's just the signs in the middle are direct opposites of each other. So a minus b and a plus b. Now, what makes conjugate pairs so nice is that when you multiply the two binomial conjugate pairs together, you get x squared minus 3x, and then you're going to get plus 3x minus 9. What makes conjugate pairs so special is the middle term right here. This middle term will always cancel itself out. It will always cancel itself out. So you can save yourself a lot of time if you recognize, oh, I have conjugate pairs. Therefore, I don't have to multiply everything out. All I have to do, and I'm going to color code, all I have to do is take the first terms and multiply the second terms. And then directly in the middle, make sure you put, come on, there we go. Make sure you put this minus sign in between the two. And that's it. That's all you got to do. So like, for example, I'll do a difficult example now. Let's do 5m minus 9n times the quantity 5m plus 9m. So notice here, conjugate pairs. You got the same terms, just opposite signs for the binomial. So the only thing I'm going to do is multiply those two terms together first. 5 times 5 is 25. M to the second, put a minus sign, and then multiply the last terms together. 9 times 9 is 81. N times n is n to the second power. And that's it. That's as hard as it gets. So then the question becomes, all right, well, what about if we wanted to divide polynomials, okay? So this is going to be part 2. Divide polynomials. Excuse me. So with dividing polynomials, all right, there are two cases. Case 1, this is the happy case. This is the one we like. This is when the divisor is a monomial. All right, so an example of this would be something like 20x to the third plus 15x to the second minus let's say, I don't know, we'll just say x. That's fine with me. Divided by 5x. Our divisor, which is the 5x, is a monomial. And when you have this case, and like I said, this is the best case scenario, when you have this case, all you have to do is separate terms. So 20x to the third divided by 5x plus 15x to the second divided by 5x minus x divided by 5x. And from here, apply your rules for exponents. 20 divided by 5 is 4x to the second plus 15 divided by 5 is 3x minus the x is reduced, but that 5 is in our denominator, so it just turns out to be 1/5. And that is how you divide when you were talking about dividing polynomials where the denominator is a monomial. That is, like I said, that is the best case scenario for us. Let me do one more example. So we're going to divide. Let's go negative 48, a to the 8th, b to the 4th minus 36, a to the 6th, b to the 5th, divided by negative 6, a to the 3rd, b to the 3rd. So if I write it out as a fraction first, notice that our divisor is a monomial. Best case scenario. So what we're going to do is separate. Negative 48, a to the 8th, b to the 4th over negative 6, a to the 3rd, b to the 3rd, plus negative 36, a to the 6th, b to the 5th over negative 6, a to the 3rd, b to the 3rd. And now all we have to do is just reduce accordingly. Negative 48 divided by 6, or I'm sorry, negative 48 divided by negative 6 is positive 8. A to the 8th divided by a to the 3rd is a to the 5th. B to the 4th divided by b to the 3rd is b to the 1st. Plus, now we have negative 36 divided by negative 6. So a negative divided by negative, this is going to be positive 6. A to the 6th divided by a to the 3rd is a to the 3rd. And b to the 5th divided by b to the 3rd is b to the 2nd. All right, so very straightforward. Just separating, applying your rules for exponents. The question becomes, I don't want to do an example. What if you don't have a monomial? All right, so this is our second case. In this case, we don't like that much. And the reason, it's very repetitive, but you can easily make a mistake. You got to use long division. So let's just recap what long division is first. We're going to divide 5 into 1,943. So remember, you were asking yourself, 5 goes into 1 how many times? So 5 goes into 1 how many times? The answer is none. So then you say 5 goes into 19. The answer to that is going to be 3 times. Oops. So you put a 3 in the quotient. Then you take 3 times 5. That gives you 15. And you subtract. 19 minus 15 is 4. You carry down to 4. And the entire process repeats all over again. You have a new, and I don't know if I said this earlier, but you have a new dividend. That's called the dividend. Let me write that out cleaner. And you ask yourself, 5 goes into 44 how many times? Well, the answer to that is going to be 8. So that's going to give you 40. You subtract 40. 4 minus 40 is 4, and you drop down to 3. And the process repeats all over again. 5 goes into 43 8 times. 43 minus 40 is 3. And then a lot of us were told back in the day that the answer is 388, remainder 3. But the best part about this is that when I ask you as the student, okay, well, explain what that means. 388 remainder 3. Some can do that very quickly. Others, it takes a little bit more time. But what you got to remember here is this. When we are talking about division, what I'm really asking you to do is find out how many groups of 5 can be created with 1,943 objects. The answer to that is 388 with 3 left over. Okay? That is the very surface level answer. However, if you remember, if we were to take our calculator, all right, so let me get out the detached LCD. So if we were to take our calculator here and do the same exact problem, 1,943 divided by 5, notice we get 388.6. The calculator doesn't say remainder 3. So the idea behind this is, well, wait a minute, where is the 0.6 coming from? The 0.6 is coming from the fact that the real answer to 1,943 divided by 5, the real answer is 388 and 3 divided by 5. That's what we should be writing, okay? Now, if you can remember that from a long time ago, then doing long division with polynomials is actually very straightforward. It's just very repetitive. So if you give me a minute here, I'm going to write down the problem. I'm going to write the setup, and all I want you to do is just kind of follow along as I'm doing this. Once you see it, maybe go back, rewind the video, and then watch it again and write through the problem as I'm going through it, okay? So like I said, just give me a second. I'm going to pause the video, set everything up, and then unpause. Okay, I'm back, and here is our problem, and here is our setup. And like I said, if you write it out and you just follow these steps using long division, these problems are not difficult. You just got to follow along. So in order for us to use long division to find a quotient of y to the second plus 10y plus 21 divided by y plus 3, the first thing we got to do, all terms must be in descending order of degree, and 2, no missing terms. So if we looked at our dividend, I'm going to write it underneath. This is our dividend. All right. Notice it goes from y to the second plus 10y plus 21. So it's in descending order, no missing terms. And our divisor is y plus 3. So notice that is also in descending order, no missing terms. So check and check. Now we know we're allowed to use long division here, okay? And let me show you how this works. The first thing is we got to know how to set up the problem. And we set it up by putting the divisor on the outside. And then underneath the long division, I guess box or bar, whatever you want to call it, the dividend goes inside. Our result will be the quotient, and that is up top. And if we have a remainder, it's going to be down here. All right? So our remainder will be down here somewhere. Okay, so that's how we're going to set this up. So what I'm going to do is just kind of erase what I have here. So make sure you write this down. And then we're going to go ahead and do our problem. Okay, I'm back. Everything's erased. So here we go. Let's set up our problem. So I'm going to put y plus 3 outside. And then inside, I'm going to put y squared plus 10y plus 21. Okay? Now, step 1. You take the first term in the dividend, and you're going to divide it by the first term in your divisor. So, our first term in the dividend is y to the second. And we're going to divide this by the first term in that divisor, which is y. So, now hopefully you can see why we need descending order, no missing terms. Now, when I divide these two together, I get y to the first power. So this goes in our quotient. So I put y to the first in our quotient. Now I move on to step 2. Step 2 says take the result from step 1 and multiply it times the divisor. So our result from step 1 is y, and then we're going to multiply by the divisor, y plus 3. So that's going to give me y to the second plus 3y. And I'm going to tell you to do this. Always put this in parentheses. Okay, always put it in parentheses, all right? We're going to take that result and write it directly underneath in parentheses and put a subtraction symbol in front. And that naturally leads us into step 3, which is subtract. So I'm going to write this out. So we're going to get y to the second minus y to the second, which is 0. And then we're going to get 10y minus 3y, which equals 7y. And that's what goes here. And just like in long division, you drop down your next term, which is a positive 21. And this entire process repeats all over again. So if you watch what I'm going to erase. I'm going to erase step 1. I'm going to erase step 2. And finally, I'm going to erase step 3 because everything repeats. We take the first term in the dividend. Now, the first term is 7y now. So this is going to be 7y divided by the first term in a divisor, which is the variable y. Your divisor term will never change. It's always going to be the variable y in this case. All right? So let's go ahead and divide. We get 7y divided by y, which is positive 7. That goes into our quotient. Now, we take the step 2. We take the result from step 1, which is a 7, and we're going to multiply it by our divisor. So that gives me 7y plus 21. Remember to put this in parentheses with a subtraction symbol out front. And then finally, we subtract. 7y minus 7y is 0, and 21 minus 21 is also 0. So we end up getting y plus 7 as our quotient, which is the answer. So the question becomes, how do you check yourself? So let me show you how to check yourself. To check, your dividend must equal your quotient multiplied by your divisor plus your remainder. So in our case, our dividend was y to the second plus 10y plus 21. And this should equal the quotient, y plus 7, times the divisor, y plus 3. Oh, come on. Plus the remainder of 0. So if we were just to distribute on the right-hand side, we get y to the second plus 3y plus 7y plus 21. And notice you get y to the second plus 10y plus 21, which is exactly what the dividend is, and you know you're correct. So every single long division polynomial, which you can use this technique on any division of polynomials, will always be done the same exact way. You follow these 3 steps, and you just have to be careful, disciplined, and take your time. So I did an example here where we got a remainder of 0. Let me go ahead and show you an example where we actually get a remainder, and then we'll check it. And then we're going to do 2 more examples where things kind of get weird, where we're missing terms. And then I'm going to show you synthetic division, which is my favorite thing ever. So I'm going to erase everything. We're going to do another problem. Okay, so here's our next example. We're going to find the quotient of x to the second minus x minus 4 divided by x minus 1. So remember, set it up. Divisor goes on the outside. Dividend goes on the inside. And then from here, we're going to go ahead and just follow our steps. Step 1, first term in divisor divided by the first term in the dividend. That's going to give us the variable x. I put that in my quotient. Now, step 2, I'm going to multiply. So I take the result from step 1, and I multiply by my divisor. That's going to give us x to the second minus x. Put it in parentheses, write it directly underneath with a minus sign out front. Okay? And then from here, we're going to go ahead and subtract. Be careful. X to the second minus x to the second is 0. Then you have this, and this is where I said you got to be careful. Then you have negative x minus another negative x, which actually makes this negative x plus x, which is 0. So you would put a 0, x, and drop down the next term, which is minus 4. Okay? Like I said, you got to be careful with this. Okay? So now, process repeats all over again. So I'm going to erase all my steps. And I am very regimented and disciplined how I do this. So I'm going to do this the same exact way. I take the first term in the dividend. Well, that's going to be a 0x. And I'm going to divide it by x. So you get 0. Write that up here. Plus 0. Now, I'm going to take the result from step 1, which is 0, and multiply it times my divisor, which is just 0, which is fantastic. So let's go ahead, let's subtract 0. And remember, when you subtract 0, you're going to get negative 4. Or sorry, I'm moving too fast. So you get 0, minus 0, which is 0, and then negative 4 minus 0, which is negative 4. And then here is our remainder. So here's how we write the answer. X plus negative 4 divided by x minus 1. Now, let me show you how this works in terms of checking ourselves, okay? To check ourselves, we have the dividend, which is x squared minus x minus 4. We have to multiply the quotient, which is just the variable x, times our divisor, which is x minus 1, and then we add our remainder, which is negative 4. So, using my distributive property, I get x to the second minus x minus 4, which is exactly what we should have gotten. Okay? So, let me go ahead and do one more example. And this one, you got to be careful because something is going to happen here. So I'm going to erase, and this example is going to be much longer than this little simple one here. All right, so here's our problem here. We want to find a quotient 2, x to the fourth minus x to the second plus 5x minus 6 divided by x plus 2. Now, the first thing hopefully you notice is when I go to set this up, I am missing the x to the third term. It's not in there. And remember, you got to have descending order of terms, no missing terms. So what I'm going to have to do here with my dividend is I'm going to have to rewrite my dividend. Let me get a thinner marker. I'm going to zoom in. I got to rewrite my dividend as x to the fourth plus 0x to the third. I have to introduce that term. Minus x to the second plus 5x minus 6. So this right here is the actual dividend. Remember, descending order, no missing terms. So now, when I go to set up my problem, all right, I'm going to have to write x plus 2 for my divisor, and then my dividend, x to the fourth plus 0x to the third minus x to the second plus 5x minus 6. So notice descending degree, 4, 3, 2, 1, constant term. That is by far the trickiest part about this, all right, is that if we don't give you a term, you have to put it in. So now, let's go ahead and let's do our division algorithm is what it's actually called. First term in dividend, x to the fourth. First term in divisor, x. And that gives me x to the third for a quotient. So I put x to the third up above. And hopefully now, with the very first thing, you can see, oh, now I see why we need to put the extra term in there. It's because you actually get x to the third after your very first division. So let's multiply. So we take the result from step 1, multiply it by the divisor. That's going to give me x to the fourth plus 2x to the third. Put it in parentheses and subtract. So x to the fourth plus 2x to the third. And like I said, just be careful. I like to write these things out. So I get x to the fourth minus x to the fourth, which is 0. And then I have 0x to the third minus 2x to the third, which is negative 2x to the third. So I put negative 2x to the third and then drop my next term down. The entire process now repeats. So I'm just going to erase my work. And start all over again. My first term in the dividend is now negative 2x to the third. And I divide that by x. So that gives me negative 2x to the second for my quotient. Now I'm going to take the result from step 1 and multiply it by my divisor. So that's going to give us negative 2x to the third minus 4x to the second. I copy this with a subtraction symbol out front. All right, there we go. And like I said, I like to write these things out. So I get negative 2x to the third minus negative 2x to the third, which is really negative 2x to the third plus 2x to the third, which is 0. We get negative x to the second minus a negative 4x to the second, which is negative x to the second plus 4x to the second, which is 3x to the second. So I get 3x to the second, drop down my next term. Like I said, this isn't very difficult. It's unbelievably tedious though. Okay? So let's keep going. So my process repeats. So let me erase everything here. Like I said, we just got to be careful. All right. Keep going. New dividend is going to be 3x to the second divided by x, which is positive 3x. So I'm going to put plus 3x here. Now I take my result from step 1, multiply by my divisor. That gives me 3x to the second plus 6x in parentheses. Transfer it over to your problem. Make sure you put it in parentheses, and there's a subtraction symbol out front. Now we subtract. 3x to the second minus 3x to the second is 0. And then 5x minus 6x is going to be negative x. So we're going to write that underneath. Finally, drop down the last term, which is negative 6. Process repeats all over again for the last time. Our new divisor is negative x, divided by the first term, or our new dividend is negative x, divided by the divisor, which is x. This gives us negative 1. Take the result from step 1, multiply it by the divisor, negative x minus 2, put it in parentheses. So directly underneath, make sure it's still in parentheses, and subtract. Negative x minus a negative x is negative x plus x, which is equal to 0. And then negative 6 minus a negative 2 is negative 6 plus 2, which is negative 4. So we get negative 4 as our remainder. If you want to write the answer, it would be x to the third minus 2x to the second plus 3x minus 1 plus your remainder, which is negative 4, over x plus 2. So this would be like the proper technical way of writing the solution. And finally, if you wanted to check yourself, like I said, you got to make sure that you write down your dividend correctly. So our dividend is x to the fourth minus x to the second. You don't need that 0x to the third thing here, all right? Because you just want the dividend. So it's x to the fourth minus x to the second plus 5x minus 6. And then you take the quotient times the divisor plus the remainder. So the quotient, remember, was x to the third minus 2x to the second plus 3x minus 1. The divisor is x plus 2. And then your remainder was minus 4. So I'm going to go ahead and check this for us. We're going to take x to the third and distribute it. So we get x to the fourth plus 2x to the third. And I'm just going to continuously do this using that vertical method to organize everything and just make this all look all nice and neat, okay? So like I said, we distributed the x to the third first. Now we're going to distribute the negative 2. So negative 2x to the second times x is negative 2x to the third. Negative 2x to the second times positive 2 is minus 4x to the second. So there's that distribution. Now let's distribute the positive 3x. 3x times x is positive 3x to the second. 3x times 2 is plus 6x. And finally, distribute the negative 1. Negative x minus 2. Let's go ahead and go straight down. You get x to the fourth plus 2x to the third minus 2x to the third is 0. Negative 4x to the second plus 3x to the second is negative x to the second. 6x minus 1x is going to be plus 5x. And then minus 2 minus 4. Don't forget about your remainder. And minus 2 minus 4 is minus 6. And that is exactly what we were looking for the dividend. And hopefully, all of you are sitting there saying to yourself, Floater, there got to be a better way to do this. And I'm here to tell you there is. Long division, although it is great, it works, it is extremely tedious, and it takes forever. So what I want to show you is what we call synthetic division. So there are some things that we have to worry about with synthetic division. First, our divisor must be in the form x minus c. Now, the c is going to be a constant, all right? In the event, put a star. In the event your divisor looks like this, like let's say like x plus 2, you're going to have to rewrite it as x minus negative 2, okay? So in this case, c equals negative 2. However, if it's already in the form x minus a constant, then c equals only the constant. So hopefully you can see the difference. If it's in the form x plus 2, rewrite it as x minus a negative 2. Or, like I said, x plus c, rewrite it as x minus negative c. Okay? But if it's already in the form x minus a number, you are good. Just label what that number is. So that's the first step, or that's the first thing. Second thing, just like long division, descending degree, no missing terms. which means if you're missing a term, you're going to have to add it in there, okay? And then the third thing, and this is the one we always have to remember, after synthetic division occurs, the result will start, with 1 degree less than the dividend, okay? Now, step 3, maybe you don't know what that means yet, and that's okay, but I'm going to show you what it means. We're going to do the same exact problem that we just did, okay? I'm going to do it twice. The first time, I'm going to do it slowly so you can see it. The second time, I'm just going to do it quickly so you can see just like how efficient synthetic division is. So here's our problem right here. We want to find the quotient 2 x to the fourth minus x to the second plus 5x plus 6 divided by x plus 2. Like I said, I'm going to do the same problem using synthetic division. All right, now, here's what we got to do. Number 1, step 1, divisor must be in the form x minus the constant. So I'm going to have to rewrite this as x minus negative 2, which means c equals negative 2. Okay, step 2. Remember, descending order, no missing terms, and hold on a sec. Hopefully you're sitting there yelling at the screen. I have a typo here. This should have been, oh boy, thank God we didn't get through the whole problem with that typo. This should be minus 6, so make sure you correct that in your notes, okay? So, no missing terms, x to the fourth, plus 0x to the third, minus x squared, plus 5x, minus 6. And then here comes our setup, okay? So, excuse me, the setup will be the upside down like division bar. You're going to label whatever c happens to be. So in our case, it's going to be negative 2. And then we do like a long division bar, upside down. And this will represent the coefficients of the dividend. Okay? So for us, I'm going to write negative 2. And then the coefficients will be 1, 0, negative 1, 5, and negative 6. Okay? So you got to be careful here. The spacing is required, all right? But don't go overboard. Just make sure they're spaced. We are still in the setup part. You always copy the first number down. No matter what, just copy it straight down. And then whatever this happens to be on the far right-hand side, this is going to be your remainder. Okay? So please, just do me a favor. Just watch how I do this because I'm going to be writing and erasing. So it's best just to watch. I'm going to do this twice, and then I'm going to do it quickly so you can see just how efficient synthetic division is. All right? So I'm going to get out a different marker. Okay, here we go. You're going to take negative 2 and multiply it times 1. Okay? So negative 2 times 1 is negative 2, and you write it directly underneath the next column. Then you're going to add going straight down. So 0 plus negative 2 is negative 2. Now the process repeats all over again. You're going to multiply negative 2 times negative 2, which is positive 4. Then you add straight down. Negative 1 plus 4 is positive 3. Process repeats. Negative 2 times 3 is going to be negative 6. 5 plus negative 6 is negative 1. And then finally, you're going to multiply negative 2 times negative 1, which is positive 2. And negative 6 plus 2 is negative 4. Now, do you remember back up above here where I said step 3, after synthetic division occurs, the result will start with 1 degree less than the dividend. That's exactly what happens here. We started with x to the 4th power. That's what this right here represents. It represents 1x to the 4th. After synthetic division, this number down here is 1 degree less. So this coefficient is 1x to the 3rd, and then you just follow it straight down. So you get 1x to the 3rd minus 2x to the 2nd plus 3x minus 1, and then you have your remainder of negative 4 over x plus 2. And if you look, this result is the same exact thing as what we had all the way up here using long division. So let me show you that one more time. I'm just going to erase some stuff. All right, and we're going to just speed this up just a little bit, okay? So hopefully here you remember the process. Remember, when you come diagonally, you multiply. Result goes right here in that little circle. Then you add. Process repeats over and over and over again, okay, until you're done. Oops, went too far. Sorry about that. All right, so here we go. Negative 2 times 1 is negative 2. 0 plus negative 2 is negative 2. Negative 2 times negative 2 is positive 4. Negative 1 plus 4 is 3. Negative 2 times 3 is 6. Sorry, negative 6. 5 plus negative 6 is negative 1. Negative 2 times negative 1 is positive 2. And negative 6 plus 2 is negative 4. We started off with a polynomial x to the 4th. Therefore, our solution, or our quotient, because this is what this is our quotient, all right, is x to the 3rd. So x to the 3rd minus 2x to the 2nd plus 3x minus 1 with a remainder negative 4 over x plus 2. And that is how we go ahead and perform synthetic division. Now, synthetic division only works when a divisor is in the form x minus a number. So let me go ahead and let's do an example where it's already in that nice form and everything, and we got nothing really to worry about. Okay? So use synthetic division to find the quotient for three x to the 4th minus 11x to the 3rd plus 2x to the 2nd plus 10x plus 6 divided by x minus 3. Okay, so I'm going to speed this up a little bit. We got everything that we need. Step 1, divisor is in the form x minus a constant. Check. Step 2, make sure everything's in descending order, no missing terms. Check. Now let's do our setup. Put a 3. Coefficients of the dividend. 3, negative 11, positive 2, positive 10, and a 6. Copy down the very first term, which is a 3. I know whatever number's on the far right-hand side, if it's a number, could be 0. But whatever it is going to be the remainder. And from here, we go ahead and do our process. 3 times 3 is 9. Negative 11 plus 9 is negative 2. 3 times negative 2 is negative 6. 2 plus negative 6 is negative 4. 3 times negative 4 is negative 12. 10 plus negative 12 is negative 2. 3 times negative 2 is negative 6. And 6 plus negative 6 is 0. So there is no remainder for this. We started with a polynomial that was x to the fourth. Therefore, our quotient will be 3x to the third minus 2x squared minus 4x minus 2 with no remainder. And that's it. That's as beautiful as this gets. Now, there is one really cool thing that I want to show you, okay? And it's called the Remainder Theorem. And it is directly linked to synthetic division or even long division in general. They're all linked. And what this Remainder Theorem says, all right, is it says this. And you know what? I'm just going to copy and paste it directly from your book. So just give me a second here. I got to go into 5.4. And it's all the way at the end. Nope. Here it is right here. This is one of those theorems that is just so cool. And if you were taking higher order mathematics, like pre-calc or calc, and yes, I do teach all them, we actually use this theorem a lot. So what the Remainder Theorem says is this. It says if you have a polynomial function and it is divided by x minus c, so that looks familiar from synthetic division, then the remainder is f of c. Okay? What it means here is this. All right? We're going to do the same problem that we just did, which is this right here. Okay? We know that when we use synthetic division, and we could use long division, but if we use synthetic division and we divide these two polynomials, notice we got a remainder of 0. What the Remainder Theorem says is this. Okay? I'm going to copy and paste this. What the Remainder Theorem says is that if I were to take c equals 3, okay, which is the x minus c thing right here. If I were to take c equals 3 and substitute this into the polynomial, in other words, if I were to evaluate f of 3, which is equal to 3x to the fourth minus 11x to the third plus 2x to the second plus 10x plus 6. If I were to take this 3 and substitute it into x and evaluate, I am telling you right now, you get 0 as a solution. Because the Remainder Theorem says, and let me erase this real fast, because the Remainder Theorem says that if you were to take whatever c is and evaluate it inside the polynomial function, f of x, that will tell you what the remainder is at the very start of the problem. So let me show you what I mean here. I'm going to cheat. I'm going to go ahead and use my calculator. I think it's really important that if we spent money on these fancy calculators, that you know how to use them. If not, you could do this by hand, or you can go ahead and I'm sure you can find something on the internet. But what we are going to do is we're going to store 3 in for x. I'm going to show you how to do that. So you type in 3, store x. And that's what it should say on your screen, and you hit enter. If you have a different calculator like Casio or something like that, YouTube will be your best friend. Just YouTube a video and try to find it. If you can't find it, let me know. I'll find a video for you. But anyways, so now that we have 3 stored for x, we're going to type in exactly what that polynomial is directly above. So I'm going to move this real fast. There we go. So watch this. 3x to the fourth power minus 11x to the third power plus 2x to the second power plus 10x plus 6. And remember, the Remainder Theorem says if you took 3, substitute it in, it's going to tell you what you get as a remainder. We know from synthetic division the remainder is 0. So when I hit enter, I better see 0 on my calculator. And that's exactly what we get. Unbelievable. It's so nice. And the applications to this, crazy. Okay? crazy. This is when you can really start looking at higher order polynomials and figuring out how to factor them and doing all this other stuff. All right? Let's try the previous example here. So let's do this one right here. All right? We know that when we did our synthetic division here, we ended up with a remainder of -4. All right? So let's get out the calculator. Let's demonstrate that you get -4. So give me 1 second. Here we go. So remember, C was -2 in this situation. So -2, store an X. There we go. Now I'm going to type out the polynomial, X to the 4th minus X to the 2nd plus 5X minus 6. And remember, according to the remainder theorem, if you take -2, substitute that into the polynomial, it will tell you what you should get as a remainder after a division, and we get -4 again. So that's all I wanted to show you with the remainder theorem, okay? If you were to take pre-calc or something like that, you would learn all this other stuff like the factor theorem, the rational root theorem, Descartes' rule of signs, upper and lower bounds. I mean, there's a bunch of stuff, but it all stems back to just doing this basic stuff right here. So I hope this video was helpful. Good luck this week. I'll see you next week.